Okay, 11th grade. We're going to be starting a new chapter, chapter 16, uh, electric forces and field. Okay, and we're going to be discussing electric force right now. Okay, so in this lesson, we're going to be talking about Coulomb's law. Coulomb's law, which it's equal to electric force equals Coulomb constant times charge 1 times charge 2 divided by distance squared. F electric equals QC times Q1 Q2 over R squared. Okay? Now, Coulomb's law, again, it says electric force is equal to Coulomb constant times charge 1 times charge 2 divided by distance squared. Now, the Coulomb constant is equal to 8.99 times 10 to the 9th Newton per meter squared, Newton times meter squared per Coulomb squared. Okay? Now, let's solve the formula. Let's solve the Coulomb constant for Q1 or for Q2. It will be the same process. Okay? So first, step 1 will be to multiply both sides of the equation by radius squared. So we get electric force times radius squared equal Coulomb constant times charge 1 times charge 2. So if you're going to solve for charge 1 or charge 2, all you have to do is divide by Coulomb constant times charge 2 if you're solving for charge 1, or Coulomb constant times charge 1 if you're solving for charge 2. So we get, in this case, charge 1 equals electric force times distance squared over Coulomb constant times charge 2. Okay, this will be how to solve for one of the charges. It will be the same process if you're solving for charge 2. Okay, now how do we solve for distance? Simple. First, we multiply again both sides of the equation by radius squared. So we get electric force times radius squared equal Coulomb constant times charge 1 times charge 2. Now we divide both sides of the equation by the electric force. So we get that the distance squared equals Coulomb constant times charge 1 times charge 2 divided by the electric force. And all you have to do is find the square root on both sides of the equation. So you get distance equals the square root of Coulomb constant times charge 1 times charge 2 over electric force. And this will be the formula for solving distance. Now, so let's do sample problem A. Okay? It says the electron and proton of a hydrogen atom are separated on average by a distance of 5.3 times 10 to the negative 11 meters. Find the magnitudes of the electric force and the gravitational force that each particle exerts on the other. Okay? So, what information is given? We know that R will be equal to 5.3 times 10 to the negative 11 meters. Now, we have to find the mass of the electron and proton, and we're going to have to find the charges too. So where are we going to find that? On page 560, we have a table, and we have that the charge for the electron is negative 1.60 times 10 to the negative 19, and the charge for the proton is positive 1.60 times 10 to the negative 19 Coulomb. Okay, now the mass of the electron is 9.109 times 10 to the negative 31 kilograms, and the mass of the proton is 1.673 times 10 to the negative 27 kilograms. Okay, and so what we're looking for is the electric force and the gravitational force. Okay, now for the gravitational force, we're going to use Coulomb's law. For the electric force. Electric force. So the electric force using Coulomb's law was Coulomb constant times charge 1 times charge 2 over distance squared. Now, the signs for the charges, it will be indicating us directions, okay? Now remember that equal charges, not equal charges, sorry. Opposite charges, they're going to have an attraction, and opposite charges they will repel. Same charges will repel. So in this case, notice that the electron is negative and the proton is positive. Okay. In the formula, we are not gonna be using the signs. We're just gonna be using the values. So for the electric force, will be equal to the Coulomb constant. Coulomb constant was equal. Sorry, I forgot to write that. Coulomb constant was equal to 8.99 times 10 to the 9 Newton times meter squared per Coulomb squared. Okay, so constant Coulomb will be equal, the electric force will be equal to the constant Coulomb, 8.99 times 10 to the 9 Newton times meter squared per Coulomb squared, times charge 1, 1.60 times 10 to the negative 19, times charge 2, 1.60 times 10 to the negative 19 Coulomb, divided by the distance, which was equal to 5.3 times 10 to the negative 11 meters squared. Okay, so here I'm going to put Q, instead of writing Q1 and Q2, we can put QE for the electron and QP for proton. Okay, now we take out our calculator, and here notice meter squared is going to be canceled here. Coulomb times Coulomb, that will be Coulomb squared, we can cancel. So our electric force will be just in newtons. Now once we multiply, we get that the electric force will be equal to 8.2 times 10 to the negative 8 newtons. Okay, that will be our electric force. Now, we have to find the gravitational force. So here, we're going to be using Newton's law of gravitational force, of universal gravitation, I mean. We studied this in chapter 7, circular motion and gravitation, and the formula was gravitational force was equal to G times mass 1 times mass 2 over distance squared. Okay, now G is a constant. This is equal to 6.673 times 10 to the negative 11 newtons times meter squared per kilogram squared. Okay, again, this is in chapter 7. You can go back and review this. So now all we have to do is substitute. Instead of writing mass 1 and mass 2, we can put mass for the electron and mass for the proton. So we get that the gravitational force would be equal to 6.673 times 10 to the negative 11 Newton times meter squared per kilogram squared times mass of the electron 9.109 times 10 to the negative 31 kilogram times mass of the proton 1.673 times 10 to the negative 27 kilograms divided by the distance squared, 5.3 times 10 to the negative 11 meters squared. Okay, and here we notice meters squared, we can cancel here. Kilograms times kilograms, that's kilograms squared, we cancel here. So we get that our gravitational force will be newtons, and once we multiply, we get that the gravitational force will be 3.6 times 10 to the negative 47 newtons. Okay, since the electron and the proton have opposite signs, the electric force between the two particles is attractive. Okay, keep that in mind. So this is how to find the electric force and the gravitational force between an electron and a proton. Okay, so that's what we're going to be doing in sample problem 8.